Thanks everyone for coming. Excuse me if my voice doesn't sound as nice as the previous panel, as some of you would have realized. So today we are going to speak a lot on labs, a topic that is not often covered when it comes to energy reduction, especially in IHLs. So today's agenda will be as follows. Why they are so energy intensive, what are we doing to try to green labs or reduce the energy footprint of our labs. I'll talk a bit about the NUS Green Lab program. A lot of ideas were drafted from the BCA Green Lab program from 2017. Noel is not here, I think, so he'll be interested in this. We also talk about designing a best-in-class lab building, as well as an overview and summary. So a bit about myself. Contrary to popular belief, I'm not actually a lab person. I spent majority of my work life in the marine sector, but because I do a lot of energy audits, energy management, and I'm always trying to fiddle around with ACMV technology, and ventilation in labs is always a key contributor towards energy consumption, and that's how I got into this. So a few things I do is basically tackling the number 1 and number 2 energy consuming buildings in NUS, basically S9 and MD6, which I'll touch on later. So just to throw a question out of the floor, and maybe this is not for those people who are very proficient with energy. Can anyone second guess what percentage of energy is taken up by labs in NUS? This is not for you. This is not for you guys. not for you guys. Anyone can second guess? No prizes though? Yeah. 80-90%. Wow. Then this panel needs to go on for 5 hours. Okay. Any other guesses? 30%. Okay, sure. So actually, it's more than half. So 54% of our energy footprint actually comes from labs, and that's the reason why it's imperative that we focus a lot of our efforts into reducing the energy there. To give a context, these are the top 10 energy consuming buildings in NUS. If you look at 1 and 2, they themselves take up almost 14% of NUS's energy footprint, MD6 and S9. And if you look at the total percentage, right, the top 10 buildings in NUS account for 1/3 of NUS's energy consumption. So which is why we are focusing a lot of efforts, both on the top 10 as well as labs. So why are they energy intensive? I'll run through a few things here. They have high ventilation rates. Basically, a lot of air needs to enter and a lot of air needs to be exhausted out because of chemical dilution and to remove toxic fumes. Most labs do not allow recirculation because you're supposed to exhaust out the toxic air. Dehumidification, Singapore is a really humid place, as you all know, so we can't just bring the air inside, cool it, and then let it run. We need to have separate equipment just to dehumidify the air. Equipment load. So lab equipment are not what you find typically in your houses. So a lot of the equipment there are energy guzzlers, like freezers, ovens, centrifuges. Basically anything that requires a lot of heating, a lot of cooling, they are energy guzzling equipment. And some labs in NUS, or quite a lot of labs in NUS, actually have special X-ray machines, electron colliders, which they themselves are a separate behemoth themselves in terms of energy. Fume hoods. This is one item that is quite often misused in NUS. I'll explain a bit later, and one of my presenters will also explain this in greater detail. So basically, they are a safe space to do your experiments, and there's always exhaust going out. But if it's misused, it can really spike the energy consumption of a particular building. And a lot of labs are controlled environments. So biosafety level 3, we have 1 in NUS on top of MD6. So that is basically the BSL3 lab in MD6 consumes 7% of MD6 itself. Just that one lab on half a floor on level 15. So those are areas where the requirements are very stringent. It's governed by MOH regulations. So it's not something that we can just enter and tweak the systems. In fact, most of us here, all of us here, actually can't even enter that particular lab. I've not entered one before. So what are we doing? I'll give you a high-level overview. Firstly, we have done comprehensive energy audits or level 3 energy audits, namely on MD6. And after that, we do energy walkthrough or energy profiling. So this is more to give the faculties, the users, an idea of where their buildings are in terms of energy use so that they can help us on this journey together with us. We replaced a lot of deep freezers in NUS. They are a big energy consuming equipment in labs. Again, air change rates, this will be touched on by a fellow presenter, Subhasa, later in greater detail. why we need certain air replenishment ventilation rates in labs. I'll talk about the NUS Green Lab program. And we are now touching on the very, difficult side of things in terms of energy modeling towards trying to really go as slow as we can in terms of air change and dehumidification technologies. So we did an audit in MD6. So MD6 consumes 7% of NUS's energy in FY 2022. So we came up with this pie chart. Of course, this is a simplified pie chart. And we generated an energy reduction target. So this is basically the annual energy. So just by doing optimized ventilation, we save 410 HDB flats a year. And that was a zero capex effort. It was just on tweaking. So along the way, we have freezer change-out LEDs and dynamic lab ventilation and humidity. So we are trying to hit from 19.3 to 13.4 gigawatts hour in about 2 to 3 years' time, and that's about a 30% reduction. Yep. And for our brownfield building, we are really trying to push the boundary over here. After that, we actually generated energy profile. So this is a typical engineering lab building. If you realize, lab equipment themselves account for more than 1/4, which is why you have to work with the lab users. I can't just enter a lab and then say this equipment is not supposed to be used, right? And interesting for science, you have different types of energy consumption for different types of equipment, plant growth chambers, incubators, ovens. So we're trying to see how we can optimize the usage with the science users. And last of all, medicine lab building. And a lot of our efforts are actually in the medicine faculty as well. So we collaborate with the users to make sure the equipment is used optimally. And we work with procurement to specify highly efficient equipment when they next purchase their equipment. And we have targeted interventions for the infrastructure side. So this was one project that we recently ran and completed. MD6, if you realize, freezers flagged out as a very high energy consuming entity in MD6. So we actually did a physical stock take. We literally walked the whole campus labs together with some of vendors to take a stock take of the freezers, the deep freezers. We tabled a proposal, and we actually replaced more than 170 ultra-low temperature freezers or ULTs with pretty good savings of more than 2 gigawatt hours or a kiloton of CO2 per year. So this is the item that we're trying to do. We are basically doing energy modeling towards dynamic air change. So everything in Singapore, as touched on earlier regarding ERPs, right, is going demand-based. It's no longer locked to time-based. So we are trying to say that if a lab requires X amount of air at a particular time, it's only supposed to deliver X. It doesn't mean that at 10 a.m. it's delivering something and 10 p.m. is delivering something. We're moving away from time-based. Everything is going to go to demand-based. So what do? So we did a modeling study, the 3D lab orientation, occupancy, plug load profile, and all the existing controls in the ACFA system for labs. We throw them into a very complicated simulation software, and we come up with a chart to say that basically what it means that if you have more greens, the temperature is optimal, 23 to 25, and the green on the right-hand side is basically, it's at the right relative humidity, like 55 to 65%. And the conclusion is that the air change can be lowered by half as compared to the current air change in most of the labs without impacting thermal comfort in labs through the energy modeling study. So the NUS Green Lab program is a voluntary initiative by us to try to get the lab users to join, to have sustainable practices in their operations. And this goes beyond the BCA Green Mark because it's slightly curated for NUS labs. So they have a checklist. This is a sample of the checklist that they need to fill up. And it'll be a back and forth exercise with us. So we'll do a site assessment, and then we'll actually get them certified. So these are real certificates of those labs that have actually gotten the NUS Green Lab certificate. So you can see that medicine and even Environmental Research Institute in GLab over here. So we are also designing a highly efficient lab building. My moderator, Cheryl, is actually the project manager for this building. So you're welcome to ask her a lot of questions on this later on. Yeah. So this is a rendition of how the building is going to be. And if you look at some of the metrics over here, we are really trying to push the EUI down. We're trying to go for something below 250. For context, most lab buildings in NUS are running at about 400 or 350, 380, and so on. So the PV generation is going to be about almost 10% of the building's energy consumption. And one thing we're really trying to push is we're trying to get the 5 Green Mark Sustainability badges. So far in Singapore, there's only 2 buildings that have these 5 badges, and none of them are lab buildings. So I think Cheryl has a lot of work on her plate to try to get this achieved. Yeah. For context, an award-winning building, Harvard University Science and Engineering Complex, the EUI is 263, and we are trying to go to 248 through different measures. So in overview and summary, I'll talk about 3 pillars of green labs over here. The first thing is infrastructure, which refers to your AHUs, your chiller plants, your cooling towers, like what Wei Yang mentioned earlier. So aircon and dehumidification. So what is the exact temperature needed? Like earlier you mentioned that they want it to be very cold. Do they really need it to be so cold? Sometimes I go in and see they put it at 22 and then they're wearing a jacket. Yeah, and then they're asking why is it so cold? I should ask them why you're wearing a jacket. So what do we really need in terms of aircon and dehumidification? So the air change rates, is there more volume than necessary being pumped in? And that's where the energy modeling study is coming in to say there's a lot of air, we can reduce it without impacting safety and the lab thermal comfort. And this might seem very trivial to your lighting, but so lighting these days is not just changing to LEDs, it's already do zonal motion sensors and all that. So one lab building in NUS, the motion sensor is actually located at the wrong side, and that's triggering lights to turn on at night. So even when you design it rightly, right, design for motion sensors, they need to be placed at the right building. So again, a lot of retro commissioning, similar to what Bertrand mentioned earlier, which we are doing in labs. Second thing, the lab itself, we need to have efficient equipment, such as the deep freezers. Using them properly is another thing. You can have the most efficient equipment, but if you misuse them, then it's not going to work. For example, you can have the most efficient freezer, but if you keep opening it 10, 20 times a day, you never maintain, there's a lot of ice buildup. I have seen a fridge where there's only 1 test tube inside instead of filling up everything. So these are user misuses of the equipment. And of course, we're also working with our procurement colleagues to specify energy metrics into equipment. And last but not least, the users themselves. So firstly, they are the ones running the operations. They need to be fully aware. And only after they're aware, then they can change some of their behavior to make sure that they are good environmentalists without impacting their own operations. And then we can operationally optimize how they actually run their labs. So all these 3 work hand in hand. So you can have the best environmentalists, but if your chiller plant, your AHU, and your equipment are inefficient, there's only so much you can do. If your equipment is all optimized, it's basically the class-leading equipment in the entire lab industry. But if your user comes in, switches it on, and never switches it off, it's not going to work as well. So these are 3 things we are actually looking at towards the NUS, towards greening the NUS labs. So thank you for that. I hope it was insightful. It was a good insight to NUS labs for you all. Thank you.